This is a lesson for Chapter 5, Section 4, titled Solving Special Systems of Linear Equations, Day number 1. And so basically what we're looking at here are three different types of answers. See, when we're dealing with a system, we've always had this situation where we have one solution where the lines intersect, and the solution is right here. Again, that point of intersection is that one solution. Well, we can have another situation where if the lines are parallel, they're not going to cross. The lines will not cross. Will not cross. And so if they don't cross, that means we don't have that point where the two lines cross, and so we don't have a solution. So this is considered a no solution. And then we have infinitely many solutions where the lines are the same. So one line is right there, and we have another line right on top of the other one. So all these points that make up that line are solutions. And so that's why we say there's infinitely many. So let's take a look at some different scenarios and see what happens. And so when we're doing this section, we can either use substitution or elimination. When the variable is by itself, substitution makes the most sense. And so I'm going to do that. I'm going to put negative 5x minus 2, which is what y is, in the other equation in place of y. So if I do that, I have 5x plus, and then I write down that expression, negative 5x minus 2. And that all equals 0, it says. And so when I collect these two terms right here, they're going to cancel. 5x minus 5x makes 0. Minus 2 equals 0. So when we end up with this situation, when we're solving an equation, all the variables cancel, and we're left with a false statement. What that means is that the slopes were the same. And so that means that the lines are parallel. And we'll say lines are parallel, so they will not cross. And so what that tells us is that there is no solution. Therefore, there is no solution. So that's what we end up looking for. So if we end up seeing that situation where we have two expressions, or one side of the equal sign and the other side of the equal sign, and the numbers do not equal, and we have that all variables cancel, and that's our situation, then we have no solution. So let's take a look at the next one. Again, a good substitution problem. I'm going to take that 2y plus 10, I'm going to put it in place of the x in the equation below. So I've got 2, then I write the expression, what x is, 2y plus 10, and then plus the 3y equals negative 1. So I use that distributive property, and I've got 4y plus 20 plus 3y equals negative 1. So I'll go ahead and subtract that negative 20, and right away, when I go ahead and collect these two terms, you see the variables did not cancel. So when the variables don't cancel, that means we do have a solution. And so when I go ahead and solve further, I'll find out what the y component of that solution is, negative 3. So once I get that, I go ahead and substitute back into the other equation. I'm going to put in for this top equation, x is 2y plus 10. Well, y is negative 3, so I'll put in negative 3 in place of that y, and then add the 10. So when I do that, I get negative 6 plus 10, and that gives me 4. So x is 4 when y is negative 3, so that's my ordered pair. That's the solution. That's the one point in this problem where the two lines have the same value. So let's take a look at the next one. It's a great elimination problem. You see how the y's, the equal sign, the x's, the 10, and the negative 60 are all in line with one another. So to solve this, I'm going to make these equations equivalent, or at least try to cancel out either the x's or the y's. So when I do that, I see that I could divide this 12, 24, and 60. All of them have a common factor of 6. So I'm going to divide by 6. And so if I do that, I'll divide every term by 6, and I've got this, negative 2x plus 4y equals negative 10. And so I'll go ahead and bring this one down, and notice how I got 2x minus 4y equals positive 10. So when I add these two equations together, I get this situation. These cancel out, so I'm left with 0 equals, and then these numbers cancel out, and I'm left with 0. So if I get an identity That's not a no solution. So that's the opposite of a no solution. That means we have infinitely many solutions. So infinitely many solutions because the lines are the same. We have the same line. That means all the points on one line are going to line up with the other because they are equivalent. And so that's our 3 different scenarios that we'll end up seeing on tonight's homework. Good luck.